Today's webinar is about getting started with Kubernetes on AKS using Pulumi. Just something for everybody, so there is no disappointment. I'm not going into the details on how Kubernetes is working. So we have plenty of other webinars for this. There are also plenty of resources available. So what we're going to focus here now is, with a little twist, is how to create a Kubernetes cluster on Azure using Pulumi and to deploy workload. So assuming you already know what a deployment is, what a service and config map is. So we're going to use them, but not spending too much time into explaining all the manifest, all the resource types. So just something to keep in mind. Okay, quickly to my person, Engin Diri. You may notice this from my accent. I'm based in Germany, and I'm working as a customer experience architect here at Pulumi, and too long in the business and worked mainly in the cloud transformation and enablement area, continuous everything. I was the person you called when Jenkins did not work. So, and now after that, you called me when GitHub is not working. So that's my continuous everything part. Short introduction for everybody who may not heard about Pulumi. I know that the people who already using Pulumi is like, oh, I already know how Pulumi is working, but I assume that we also have people here in the call who don't know how Pulumi is working. So I give you a very, hey, Robert from Chile. I give you a very brief introduction. What is Pulumi? And for everything else, again, we have plenty of other workshops who deep dive into the nits and grits of Pulumi. So what is Pulumi? Spoiler, yes, we are an infrastructure as code tool. We are in a similar space as other tools you may know in this area. The difference between us and other tools you may use or still use is that we leverage generic programming language to do this. So you can guess all the benefits you have using a generic programming language and the benefits of using your existing tools, for example, your existing IDEs, your existing code checkers, and so on and so on. So no need to learn anything new, which is not necessary. Just focus on what you're doing. So if you're on GoPro, if you also use Python, for example, you just keep continuing your existing tool chain, and now you're also able to create infrastructure. This is very useful for people who work maybe in teams with you, build it, you own it. You have to be also now the 100 times engineer. Hey, you are responsible now for infrastructure also. So that's a thing. And of course, it works with any major cloud provider. So there's a huge library of providers you can use. It's open source, which is nowadays very important to mention this, but we also offer a SaaS service with a very generic free tier. When I mentioned this at KubeCon, people were really surprised how much you can do on the free tier with Pulumi. And of course, if you don't want to use, you can manage your state file on your own. And there we already make the introduction about the Pulumi engine and the Pulumi programming model. This is also very interesting. Again, I will really speed run over this to have enough time for our actual part, what we're going to do. So this is our Pulumi programming model. You may already saw this on other webinars if you joined, if you're a regular. So Pulumi project is the all surrounding part, and then we're going to start to say, okay, what is a Pulumi program? So think about a folder where your pulumi.yaml file lies in, which is automatically a Pulumi program, and then inside this you can create now your actual Pulumi code, for example, depending on which programming language you use. We have the concept of stacks, which is maybe a little bit different if you're coming from an AWS CDK background, for example. We define stacks as environments, so you can give them some meaningful names like devqr and prod, but also some alphanumeric stuff some people start to do with the whole ephemeral environment movement. So it's completely up to you. And then you can guess, you define a config in your Pulumi program, which is binding for everything. And then you can fine tune it in your different stacks. You can say, okay, if I'm going to create an EKS cluster, I'm not allowing GPU support, for example, for the nodes or only 1 or 2 nodes. And then the more you go to prod, maybe the more close you come to the real environment. That's something you can do. Resources are our Lego blocks. You really where the magic happens. You can now take these low-level components and start attach them to each other. Here comes one thing. Let me click here. The input of one resource, the output of one resource can be the input of one resource. So you can create a nice chain. And this is also something when you create the chain, the Pulumi engine in the background will find out any dependencies and execute the creation or the modification of the resource depending on this dependencies, for example. So if you need, for example, to create an AKS cluster before you need to create a resource, before you need to create a resource group, and then you can create the AKS cluster. So the creation of the AKS cluster will wait until the resource group is finished and will then continue. But sometimes, for example, an Azure, I call it still Active Directory entry or creation of an enterprise application is independent, for example, from your resource group. So you can just execute this. And of course, this is very interesting if we come into the space of, hey, I'm going to provide via an IDP, for example, via some kind of experience. I want to provide a way people can influence the creation of all the resources I created underneath a Pulumi program. You can define input and output on a project level. So throwing in a t-shirt size for your Kubernetes cluster because we want to create a nice abstraction. And we all know developers really don't care about the details of a subnet and so on and so on. Just throw in some abstraction in, and then as an output, maybe they get the kube config or the IP address. So that's it from the programming model. And then the engine, there are different ways. The full power here lies in our CLI. So when I write a Pulumi program, the Pulumi engine detects which language I'm going to use and starts this language host server. Then, of course, the CLI here in the center, taking care of when the resource gets interpreted from the language. Is it a create or update? Goes to the provider. For example, in our case, we use the Azure native provider, downloads the Azure native provider, starts it in the background, communicate via gRPC for all the actions we're going to do, create, update, or delete. And the result of any action will be saved in our state, in the state backend. And as I mentioned before, you can either use the Pulumi cloud to take care of the state, save it there, and don't think about any backup or any other strategy. Or you can use an S3 bucket, for example, and just take care of the state on your own. Short notice for the Pulumi cloud here for this webinar. You should all got an invite for our demo organization on the Pulumi cloud. It is an enterprise organization, so you have for a couple of days, you have full access for all the enterprise features. It's not going to be deleted instantly, so you can keep playing around and a little bit see what other functionalities we have. So please accept and join the organization, at least to follow the webinar now when you want to see what I'm doing. Okay. And yes, I mentioned this state and secret management, everything is inbuilt. So you can use the secret management as something like batteries included, but replaceable. If you grow out of our service, you can bring your own secret managers like the Azure Key Vault and just switch this and continue using this. Pulumi deployment is something I'm not going to explain here. It's a functionality where you don't need to have any CI/CD system on board. So it's a serverless way to deploy Pulumi programs, really, really interesting. And have a look into some of the webinars around this subject if you're interested, or just check our documentation. Pulumi Insight, AI-powered search is really, really powerful. People love this, especially people who have a little bit the cloud costs inside. So they can check for resources, they can find which resource belongs to who, and then maybe if the resource is not needed anymore, just take appropriate actions. Policy as code, also a very interesting subject. We have also some webinars around policy as code. And then, of course, webhooks and MS Teams, connections and all the stuff, everything you need dashboards to have a full SaaS experience. And there's even a Backstage plugin. So if you're going to use Backstage, for example, you can use the Backstage plugin to get the information out. Okay, again, call to action for you all. As part of the workshop or afterwards, just sign up for the account and use it for free and give it a trial. The The individual account is completely free. If you want to try the organization, either this webinar organization you are already joined or just create one, it's for 40 days. It's free. So now, before we start, and now I mentioned also at the beginning, there's a little plot twist because I got several times feedback about, hey, joining a webinar, sometimes folks coming from a background where they're not developers, but they found Pulumi interesting and want to start. So here's the question. I'm not a developer. Maybe I will become a developer. Maybe I start to learn developing. So I use the term developer now a little bit generic, but I want to start using Pulumi. So what ways do we have? YAML. So Pulumi supports YAML. This may or may be not something you already knew, but you have the possibility to create inside YAML a Pulumi program using different providers, just create providers inside this YAML and then just execute this. It's very, very cool way. And we see plenty of customers of us or plenty of people who found the YAML way very interesting, especially if they come from a platform background or be part of the platform engineering team. And now comes the fun part. Pulumi supports the transformation of this YAML file. So when you decide later on, hey, we are ready for a language, or we already decided on a language, you can then just kick off Pulumi transform into your target language and you're good to go. So using Pulumi YAML maybe for a short period of time and then transfer to the language of your choice and use this then as your own bootstrapping or scaffolding to not recreate everything from scratch. So you can take stuff you already invested time into it and then use it in the programming language of your choice. For example, I'm a huge Go fan. So transforming this into Go is really a lifesaver. And of course, choices are always cool. So you don't need to transform this in a programming language. What you can do, for example, is just keep it on the YAML, but then maybe leverage some tools from the YAML ecosystem to gain some functionalities to keep your code still dry. So you could use Q using a config management language like Q or KCL. And now with Apple, we have Apple Pickle also available. So these are really, really great choices. And you can then decide to say, hey, let's use this and build up your experience from this. But under the hood, you still work with YAML, and then you just use whatever command it is to create the YAML file and say, okay, either I save this now in my Git repository, or I tell my CI system to just generate the vanilla YAML and then make a Pulumi apply. Very cool. And of course, what you can also do if you have, for example, existing Terraform files or OpenTofu files, and you're like, okay, we don't want even to lose them. We don't have the chance to start on a green field. So there are some functions we want to take with us, but don't want to spend 2 streams going on, running Pulumi on one hand, running Terraform on the other one. You can also use Pulumi convert to transform from Terraform. So these are the ways to use Pulumi. So now we come to the real part to say, okay, I mentioned this with Pulumi loves Azure. So what we have, if you go to our Pulumi package manager and type Azure, you can see that we already have plenty of providers available for you. And we're going to focus now. I focus when I use Pulumi on this too in the Azure context. In this example, we just focus on the Azure native one, because the Azure native one is the one where you have all the latest features from the Azure API available. I talked the last time with the engineers around 1 week, and then a new version of the Azure native provider is created. The Azure native provider on our sites gets created by directly communicating with the Azure Resource API, Resource Manager API, and then some ways. I'm not in the engineering thing, but they have some clever ways to generate then the different SDKs out of it. So use the Azure native provider. You also have the possibility to create these different API versions. So sometimes, if you come from an Azure background, that there are different API versions. Some functionalities are there, some functions are in a later API. Everything is possible with the Azure native provider. The Azure Classic one is something which has some kind of abstraction going on. So it can be possible that some functionality takes a little bit more time, or even the names or the properties are a little bit different and behaves a little bit differently than you would see it, for example, Doesn't mean it's a bad thing. It just want to say, okay, these are the two ways. And with the classic one, as I said, it could be this new functionalities are a little bit behind. So just keep an eye on this one. Okay, workshop time. I don't want to spend too much time on the details. So what we're going to build now is a storefront. So it's a really simple storefront. There are several microservices running in different programming languages, Node.js, Rust, and we're going to use also on RabbitMQ for the orders. And the front end is written in Vue.js, so everything is already set. We're going just to deploy this. That's awesome. So that's the demo case we're going to do, and just a short introduction for the Azure AKS service. So on a really, really high level, a Kubernetes cluster is a Kubernetes cluster. So yes, AKS, EKS, and GKE, they are managed service. There's much going on in the background. So the cloud provider takes care of the control plane, for example, managing the stuff, and depending on the price you pay and the level of quality of the service, you get additional high availability and so on and so on. So this is clear. But on a vanilla case, it is still a Kubernetes cluster, API service control plane, API server control plane. So there is no much changes. But of course, there are some details why, for example, people prefer an EKS cluster or prefer a GKE cluster. So one of them could be they are already inside this cloud. So the company is already working with Azure. I worked in different companies. There were really Azure shops. There were no rational explanation for this except of, yeah, we use Azure. There was maybe the sales team of the Azure team was very good. And yeah, we used Azure. But when you're using the managed service rather than using another way to manage to create Kubernetes cluster like cluster API or whatever, so if you're not self-managing it but you use the managed service, there are some little details. So one of this in AKS, for example, which I like very much, is the way that you have some add-ons. So there are built-in functionalities you can activate. It's the command is, for example, the Azure CLI command to see which add-ons are available. You just AZ AKS add-on list available one here. I printed out just fresh of today. For my region, for example, this is the available add-ons I can say. So I have here the Istio possibility. I can create a service mesh and so on and so on. So very cool functionalities you can get out of the box when using Azure AKS on top of the vanilla Kubernetes experience. Another cool functionality and really, really powerful because there's much knowledge behind this is the connectivity with Azure Active Directory or Entra ID. I don't know if they completely rebranded it also from the name, but under the hood, you can connect your Azure Active Directory to it and then have some special access control on this one and give different teams different ways to access this. So if they need, for example, the kubeconfig via the Azure CLI, it will be against the roles and policies you defined here, and then maybe they have limited access to this. So this is very, very cool. Another functionality which I really, really like, and I know that most of the major cloud provider also upgraded here, is the usage of Cilium. So you can, and this is something we're going to do in the demo, when you start your Kubernetes cluster or create your Kubernetes cluster, you can then opt to use Cilium, which is very cool and gives you a new whole new possibilities. And also, I mentioned this the slide before. Yeah, the additional add-ons you can just activate. I made a screenshot of my portal, so you see I can activate Open Service Mesh either via code or via the UI. So that's very cool. And yeah, that's it from the AKS side. There are probably many more functionalities you can activate, but from the fundamental, these are some of the functionalities an AKS cluster brings. The managed service, in opposite to self-create your Kubernetes cluster and then have to take care of everything else. It's not completely impossible, but we want to focus our time maybe more on the integration into existing Azure services rather than creating too much effort to connect to them or to use alternative services. Okay, I may sound like a broken record, but just accept the invite for the Pulumi Cloud to play around. And here is the link now to the workshop content. So what we are going to use now is we're going to start to create an AKS using YAML. So no programming language is needed. So all you need now is the Pulumi CLI and the access to the Azure AKS. So you're going to see now how it feels to create and to work with Pulumi YAML. And this makes life so much easier to follow along. And underneath you see, if you already have some other organizations going on, the command Pulumi org set default and then the organization name, just to make sure that the Pulumi CLI is connected there. And short to the architecture. So on the left, we have either CI systems or a person sitting on a computer. So what we're first going to create is a resource group and then the Kubernetes service. The Kubernetes service itself is going to spawn some virtual machine scale sets and so on. This doesn't matter for us. So we're going to create these two resources. And then we're going to fetch the kube config also programmatically all via Pulumi to say, get me the kube config, because we want to programmatically create inside YAML a new Kubernetes provider and then deploy our storefront using deployment service and config maps and all the stuff. Everything inside this one Pulumi YAML program, so that a customer who comes can just navigate via the IP. So the service underneath will expose is from type load balancer, will get a load balancer IP from Azure, and then you can just navigate this. Okay, so let me share my screen. So. Okay. This is my screen. And then we can look up here our example code. So let's go into the README. Let me close this one here. Okay, let's render this like this. Oh, doesn't make it big. Okay, so as I mentioned, the prerequisites is you have to get the Azure CLI activated and you have the Pulumi CLI all installed. So that's very, very important. Check out the repository, of course, navigate into the folder. And I will do this now here with a temp folder. So you can see everything is working fine. So, and I say make directories on my first, let me call this AKS webinar YAML. Then let me make this bigger. So AKS webinar YAML. So that's the first thing, creating here the folder. And I'm already logged in. So you have to use Azure login just to be sure. There are different ways to authenticate against the Azure, against your cloud provider. You could also use OIDC and all the stuff, but here for this example, I just used the Azure login. Take care that the user you're going to use have the rights to create a Kubernetes cluster and a resource group and everything you need. And you can also then, depending on which accounts, maybe you have multiple accounts, take care that you use with AZ account list or AZ account set the right account, the right subscription, and then you are good to go. So next step is I use the concept of templates here. So I can create with Pulumi new YAML. I can choose an existing template, in this case, the YAML template. If I don't know which templates are available, I can just write Pulumi new, and then I can see all the templates available. Then I can choose what I'm looking for. In my case, because I want to show you everything in the vanilla approach, I'm using here the Pulumi new YAML template. So it's the name of the template, and then I give it a go. It will ask you now in a wizard the name of the project. So in this case, I say AKS webinar YAML. That's fine. It takes the folder name. You can also use a different name if you have a specific requirement, some description, the name of the what was it? The name of the organization. So here in this case, as I mentioned before, because we already have access to our demo organization, let me see what was the name. I can just take here the name of the demo organization or whatever organization you have in the future. So, and then I say slash and I give it a name here now. Let me say Engine. Okay, so it's created now, and we see there's one Pulumi YAML file. That's all what we need with the YAML approach, nothing else. So this is something we did. The only thing I'm going to set now is I set the location, because on that generic, this is a config I just mentioned at the beginning. So I will set now globally on a stack level. I will set now the config. I say, okay, my Engine stack will always be in West Europe because I'm located here in West Europe. So now what I will have two files now. I have the file with the Pulumi YAML code, and then I have my stack where I can set additional config parameters. And it's always the name Pulumi dot then environment name and then .yaml. So not idea. Let's open this with Visual Studio Code. So yes, I trust. So as we see, this is a little bit, let me, don't want to spend the trust project. Okay, so let's open this one here. Okay, so we see that the new YAML already created some boilerplate for us. So what I'm going to do now is I'm going to delete everything until line 4, because we will create everything step by step. And let's see what our documentation says. Okay, we should now create now the resource tag. Oops. The resource tag, so this is some annotation from Pulumi YAML. So resource underneath everything with this will be created. So I will now copy paste here this resource and add it here and say, okay, create now my resource group. As you can see, Azure Native Resource Group, give it a specific name. So I call it my AKS cluster resource group. And let's make our first try and say Pulumi up. And it will ask me now, should I perform? Yes, let's go. Create, please, the resource group for me. And yeah, it created the resource group. So now we can, let me see. Where is my little window? That's clear. So new window. So let's head to our Azure portal. Resource groups, and I can see, yes, my AKS cluster resource group is created and it's completely empty. That's good. That's what I wanted to do. So let's continue. So here again, a little bit explanation. If you want to follow this later on, just follow the steps. So now we're going to create our EKS cluster. There is no log groups and workspaces for monitoring and so on going on. This is really now a vanilla Kubernetes cluster. Again, resource ID here for Pulumi, my AKS cluster. Then again, we choose the type. And here, as I mentioned, everybody who uses Azure will notice. So here comes the stuff with the whole versioning of the API. If I need some functionalities in a newer version, if I don't specify this, it will just use the current version. But here in this case, I said, hey, I want the latest 2024 API version. So I defined this, and now I set some additional properties. Important step here, except of the resource group name, is that I want to create a specific name for my node resource group, because what Azure is doing at the end, when I create a Kubernetes cluster, it will create a random name for this resource group. That may be not an issue for some people. I like it also very clean. So I say, okay, if you're going to create an additional resource group to save all the resources you need for this Kubernetes cluster, please use following naming pattern: DNS prefix And now we come to the next thing. Here with the network profile, I'm going to define that I use Cilium. Plugin mode overlay, network policies should also activate it. So later on, I'm also able to use the Cilium network policies. So this is everything needed to get Cilium up and running. Identity, system assigned, and then here for the agent pool, I'm using here standard B2 burstable instance. You can change this. This is completely up to you. Give them more memory if you need this. So these are settings absolutely for you. How can I look up this additional information? So if I go to Pulumi registry and I go to the Azure native provider and I use for managed cluster, I can see here all the informations. So here I can choose which language I would like to see, and I see all the properties I can fill out. As you can see, there are many, many, many more properties to use for. I just chose some of them. So let's head back to our code. So I'm copy pasting also the AKS part, head over to my code and just hit the new button and enter also here. Oops, you see YAML having intending, very important. So now set this up. I can again say Pulumi up. It will make a preview. Let me close this. So I cancel the preview. Let me go here. I say Pulumi up because here we can see this better now. It's the same thing. So I see now the resource group is already created. So Pulumi will give me the feedback that it's already created this one. And the new one is the cluster. So two unchanged resources and one new one. I can look up the details. Yep, that looks fine. Let's say yes. This will take exactly 300 seconds, 5 minutes. So we are not going to wait until this is finished. We just continue with our code. So that's what we did. We can now continue with the application definition. So the cluster is going to get created and we want to deploy now the application. So to deploy the application, we first need the kubeconfig file. So there is one way how to get the kubeconfig file and use this then further on in every other Kubernetes resources we're going to create via Pulumi. This is an important step. So to get the kubeconfig, we use in YAML, in Pulumi YAML, this function invoke. So I'm going to use now a function called list managed cluster user credentials. It has some arguments. So resource group name, resource name, and it will give back the kubeconfig file. So let's have a look in here. So if I go back to the registry detailed definition of the package, I look up our list managed cluster user credentials, again, different APIs, different properties, and I see again all the informations I need. So I see resource group name is important, resource name is important, and then I have some additional functionalities I can enter. So in my case, I need the resource group name and the resource name. So head back to our code. And this is just a new block. So above or wherever you want to put this in YAML, it doesn't matter. Just copy paste here this line block, go into our code. I will put it also here at the beginning and then just enter here the variables. I defined a new variable called kubeconfig and has the information. This is still running. This is fine. So now we have the kubeconfig. What we're going to use now is also to create programmatically a Kubernetes provider, a Pulumi Kubernetes provider. This is the step you see here. Again, under the resource tab, just create a new entry, call it whatever you want. Here in my case, I call it my K8s provider. It's of the type Kubernetes, and it has also properties. So now I can reference, if you can see kubeconfig, I can reference now to this kubeconfig file. Let's see. So we see list managed user credentials has a result kubeconfig, which is a list. And I can look up the list now. And it says the base 64 encoded Kubernetes configuration file. This is the result I get from the function called list managed cluster user credentials. So that's wrong why I pressed this. So and what I'm going to do now is use the informations, the value, the value here, and feed this as an input for our Kubernetes provider. So where is the Kubernetes provider? Here is the Kubernetes provider. And if we look also the API description here under provider YAML, we can see now also inputs are plenty of inputs, but the most important input is the kubeconfig. I enabled also server-side apply, sometimes some functionalities are important. For example, when the CRD has a specific size, it's always useful then to just use server-side apply, so you don't get this annotation added in your deployment. Again, this is fine-tuning from Kubernetes. But I'm going to use the kubeconfig here. So the input parameter is kubeconfig, and then I created a new provider. So let's take this also out here. How is our Kubernetes? 50 seconds, and then we can start to roll out the new functionalities. Let me look on the watch. Okay, we still have time. So I go completely down. Oh, I don't need to go down. Let's go here. So I enter now the Kubernetes provider, and I tell him, hey, go to the kubeconfig file above. And because we know it's base 64 encoded, we just need to use this function called from base 64. So we're going to decode this as an input here. No worry, it is still in the state file. It's not visible, so nobody can hack your kubeconfig. Is something which is automatically not visible in the state file. It's already encoded in the state file, but the provider needs the decoded version we get from the list credentials call here above. And that's it. So we created also the provider. So let's have a look how our deployment, and yes, the Kubernetes cluster is deployed. Let's have a look. How does it look here? So in the portal, we can see my AKS cluster is deployed. And if we see the resource groups, we also see, or we should see, where is it? Resource group. Come on. My AKS, there should normally, maybe it takes a couple of seconds to refresh the screen. We will have a look later on. So the Kubernetes cluster is deployed. It's successfully, it's running. That's nice. So let's create now call again Pulumi up, because now we create the Kubernetes provider, and we have also the kubeconfig. Again, this is something you can also do in one run. I just split it now into several runs, so for you to have to see better what I'm going to do. And as we can see, create a new resource called Kubernetes provider. So I press yes, and it should now create also the Kubernetes provider. Yes, it created the Kubernetes provider. Now have a look into our application we're going to deploy. So for this one, I will just switch to this. So this is what we're going to deploy. It's, as I mentioned, the storefront, the order service, the product service, everything written in their own language. So one using TypeScript, the other one using Rust, and then also communicating here with the RabbitMQ, and in Vue, using Vue.js as a framework, also having the front end. And this is everything we're going to deploy now. This is really quite large, because it consists of several deployments. And here, the idea is, yes, you could also deploy a Helm chart, for example. So the Kubernetes provider has also the possibility to deploy a Helm chart. You can also put this into an own YAML file, keep it in the Kubernetes native resources, and just point Pulumi to this so-called YAML file. I will show this. How does it look like? So here with YAML, you can just say config file and just point to here to the file where the YAML file lies. So this is also useful if you say, okay, there's plenty of Kubernetes resources. I don't want to transform them into a Pulumi native description. You can use the Helm chart. So here's also the possibility to call Helm v3 Helm charts. You can execute. In our example, I just want to show you that you can create everything inside with Pulumi, and then also leverage here any relation and say, okay, the output of one is the input of the other one. Makes life also easy. So what we have here is the RabbitMQ deployment, the RabbitMQ config map, the RabbitMQ service itself, so we can communicate over the service name, order service, order deployment, product service deployment, product service, the front end and the front end service. And we also have here this output of the IP of the load balancer because we just want to continue to use it. So I copy paste everything, go back into our real project underneath here, and this should be all fine. So I just copy pasted everything in, and as you can see here, one important step is I have here this so-called option where I point to this programmatic created provider. This is important because otherwise it will try to use the default provider configured. If you have the AKS cluster already configured as default default kubeconfig in your .kube folder, for example, you don't need this step. I always put it in just to be sure, because it could be possible that I change the providers in my code. Maybe in a programming language, I would, for example, loop over different providers and then use the output of different providers here. So in this case, just remember to put this option tag into it. And we can again go to Pulumi app and say now Pulumi app. And we should see a lot of changes coming through. So we see that all the services get created, the config map for RabbitMQ, and the deployments, they should get created. I say yes. And this should not take too much time because this is running now on the Kubernetes cluster in the cloud. So it should have hopefully a quicker connectivity to the containers. You see there are also some basic checks inside Pulumi. You can also deactivate them, that he waits for the service, for the deployment gets ready for the service, also that it can reach the deployment that the pods are running. And after a certain while, we see that the last of the pods hopefully get also deployed and are running too. The order service deployment, please. Okay, this is also running, and I get the IP address from the service. I'm not using now kubecutter to show you the different services. Yes, you could also get the kubeconfig now. What I will do is now I will use the UI here just to give you an idea of the workloads running. So we can see now here all the, what is the deployments. We see that the storefront, the RabbitMQ, and the product services running. We see the pods. And if we go to services, we see that here the storefront service has an IP address. I just saw it's the same IP address I also exposed via Pulumi 108, and it ends with 80. So let's see. Yes, it's the same. And if I open this page, it should hopefully render the storefront. Yes, perfect. So I have the AKS storefront running. I can now see the details of the product. I can add stuff to my cart. So add to cart. Yeah, where is it? So add to cart, cart one, add to cart. Let's see the cart. Yes. So I ordered these two products. I say checkout, and it mocks the checkout and says order submitted successfully. That's it. Create it. And last but not least, which is also very important, so we access the application with the IP. If you have, for example, the gateway API, you would navigate now with your DNS or using an ingress controller with the ingress, with the DNS you point to your cluster. This is all something you should do when you create a production ready cluster, all the functionalities. So of course you would not navigate here with a raw IP address because this could change. It's not convenient. Deleting all the stuff is very important because we want to be good cloud citizen and also want to save costs. Maybe this was just a demo test case. So I can say now Pulumi destroy. And it will ask me now, it will delete everything in the right order also. So I can now say, yep, that looks fine. This is all the stuff I would like to delete it. Ask you again, say yes. And now we can start to delete the stuff. So it starts with the Kubernetes deployments because we're not going to delete the Kubernetes cluster first when there's still workload on it, because otherwise we cannot delete this workload anymore. And we have some weird state going on because there's some deployments defined and we cannot delete this. It will take some time to delete the Kubernetes cluster. We don't need to wait this one. So let's head back to our big marker here. So gets back to the slides. So, and this is something we did now. What is this? Okay, this is some old stuff. And again, a reminder, this is the URL, just scan it. Promised it goes to the GitHub repository, and to see the code again, if you want to do everything in quiet and try this everything on your own, everything should be up and running. I just, as you see, tested this again. And yeah, that's it for the workshop. Before we head for some questions in the chat, just something which I really asking you a favor is you will get an email asking you to rate this workshop. So please give us some input on how to change stuff. We have workshop is 1 hour. It's a virtual one, so it's interesting to see how we can improve while being still interactive with you folks and give you everything you need to. And also to run maybe with more time if you have if you want to run this in quiet after the workshop, for example. So let us know. And yeah, I can handle critic also. So no, that's not true. I'm going to cry now. But give feedback. That's important. How to get involved with us. This is very important. So head to our community Slack. If you're not already member there, I'm also there. So you can ask folks from Pulumi. There's also the engineering up and running there. And you can also try our latest product, Pulumi AI, which I did not mention here now in this webinar because we have also other webinars going on for this. And upcoming workshops, which is important, what I mentioned before. So we have an AI ML workshop on GKE on the 28th of March. We have a CI/CD on AWS on the 29th. And a CI/CD pipelines with Pulumi and GitLab on the 1st of April. So these are the next workshops. Head over to pulumi.com resources for any additional one. I don't know, Diana, which one you are running the next one. So if you want to see Diana in action, just see which workshop she is running.
The 29th.
The 29th. Awesome. Yes. Yeah, that's awesome. Cool. And that's it so far. Any questions from you folks? Happy to answer them. Feel free to type to put them in.
I think there was one question to sharing the URL repo. So in the chat, there is a GitHub link for the AKS code for today.
Yes. And yeah, play around. It's really cool. And I would like to build on this. So hopefully we will have a next AKS session where we go a little bit deeper and then also try to run some large language models of it, because they announced at KubeCon this last week Kaito, the Kaito controller on Azure. where you can run different LLMs. So that's really awesome. Fran Circa asked, if you have separate environments, how would you handle different states for the stack? So they get automatically created with the specific name. So the stacks, the state. So if you use the Pulumi cloud, it will take care of this. You don't need to think about. If you're using self-managed, for example, I think in the .state folder, somewhere in the Pulumi folder, there is then a folder with the environment name, and then the state is also in. I hope is the question, Fran. Feel free to clarify again if you have anything. But yeah, you can switch between the different environments with Pulumi stack select. So if you want to do anything on an existing already running stack, just select this one and then execute. Again, if you use Pulumi Cloud, you can also create some RBugs that people can access this or not. Yeah, that's it. So we are a little bit earlier with the time. If there is no other further question, I would give you 7 minutes back, which is great. And looking forward to hear or see you in the future in any of the future workshops, or say hi in the community Slack. And thanks.